So we have a Ferris wheel. The radius is 10. So Ferris wheel, if this, so what I'm doing here, the bottom line is the ground. Okay. And it's 1 meter above. So this height right here, from here to here, is 1 meters. And one complete revolution every 20 seconds. Okay, every 20 seconds. So that means it does a full rotation from here. So let's assume we get on the bottom. We'll do a full rotation in 20 seconds. Okay. Now you know that, okay, here's the center, right? The sine and cosine curves represent it represents the circle rotating. Okay, so let's call that the y-axis. Let's call the h-axis the height, and let's call this actually t for time. Then when you get on the bottom here, we start at the bottom here. So at time 0, this is 0 time, we're at exactly 1 meter. That makes sense, right? As time goes forward, we're going to go like this, up and then down. Now they're telling us that this takes 20 seconds. So he says find an equation that gives the height above the ground of a person as a function of time, right? So we just have to get the equation of this curve here. This is an upside down cosine curve. So I know it's going to look like this. Y is equal to, it starts from the y-axis. So it's going to be a negative amplitude, a cosine of some period adjustment, right? Time, and some vertical shift. There's no horizontal shift. The amplitude is the radius, right? So the radius is given to be 10, so that's going to be 10. So that's going to be 11, and the maximum is going to be 21. So amplitude is 10. Right. Now cosine k, we know this, that 2 pi over k, so 2 pi, that's the normal period, right? If you shrink it by a factor of k, that's equal to the period. Now in this case, they tell us what the period is. 2 pi over k is equal to 20 seconds. So then k must be, right, do some cross multiplication, k must be pi over 10. So we have pi over 10 here. And the vertical shift, right, is clearly 11. That's the equation in terms of height. So we say height as a function of time is equal to this.